So we have right circular cylinder with its diameter equal to its height is inscribed in a right circular cone. Again, good picture, good picture. So our cylinder, there, this here is the height. And then what does it mean to be written in a cone? Well, the center of the cone, in this case, coincides to the center of the cylinder, which is at the center of the circle that's forming of the top and the base. And then it goes up from there until it hits. So there is a circle here that is on both. It's where the cylinder ends. Clearly, this cylinder is a little too tall, right? What we said is that this diameter is the same as the height. And so if we have to push this down, then the correct answer would be, but this is a reasonable picture. I don't want to mess it up. So maybe I'll draw another reasonable one. More like this. Right. So this is a circle that, imagine that we cut this with a slice, with a plane through the top of the cylinder. Then what we would get is a smaller cone, right? This is a smaller cone with a new little base. And actually that will help in solving. So you're going to see a lot of problems like that in calculus, where you're going to be given this cone could be skinny or really short, or tall and skinny. So there are some parameters there that could change. But suppose you're given the parameters of the cone and then find the cylinder that has the greatest volume is a very typical calculus problem. And it's not the calculus that trips up people, but coming up with the relationships. There is a right triangle. If the cone was alone without that cylinder, you would know to draw this. There is a connection between, I think this is called the slant height, and the height of the cone and the base radius. There is a right triangle there. And then there is another right triangle here, and they're similar. And that's basically the core of this problem. Now let's see, what is given is, so for the cylinder that's smaller, I'm going to use lowercase letters. So H is twice R, R to R. I'm not sure it's a good idea yet to draw that in our picture. And then the cone has a diameter of 10. That means a radius of 5. So this here is 5. And an altitude of 11. It's a little too long. It's too tall. 11. And the axes coincide. So find the radius of the cylinder. Oh, so let's call that X. And then hopefully we're not going to have to introduce anything new. Well, we will. So here is the problem. The problem is that there are two obvious right triangles similar to each other. There is this little one, and there is this big one. The problem is, first of all, the hypotenuses are useless. So we have to go with the horizontal side, vertical side. But this here, what is this? This is not, what this is take the height of take the big height, the height of the cone, and from it subtract the height of the cylinder, which I'm going to change from X back to R. I think R is, we're better off with R, because, so the horizontal side divided by the vertical side, in the bigger triangle, that's pretty easy. The horizontal is 5, the vertical is 11. Done. But we have to state that in the little triangle. So the horizontal side is R. And then what makes this problem tricky is that the vertical side is not 2R, it's 11 minus 2R. Because this here is 2R, And so this is 11 minus 2r. So that same ratio in the smaller triangle is horizontal over vertical r over 11 minus 2r. And that is our equation. After cross multiplication, it's linear in r. So we're going to be able to uniquely solve fairly easily. 55 minus 10r equals to 11r. So 55 equals to, yeah, we're tempted to say 11 minus 10. I thought that was encouraging, but that's not what's happening here, unfortunately. We have this hideous number, 55 over 21 for r, which is what? It's 2 and change. That kind of makes sense because this is 5, and so this one, 2 and change, that kind of makes sense. So we can punch it in, but the exact value is 55 over 21. So it's a little bit more than half of 5. That kind of makes sense. And then we check the answer, and it is indeed 55 over 21. Thank you for watching.